Hello, ladies and gentlemen. Today we're going to take a look at solving equations that have these rational expressions in them. So they're called rational equations. And they're basically equations that have fractions within them, and how to deal with that. We're going to take a look at that. You've done some of this previously in other math classes. So today we're going to start with two fractions, and we called that a proportion in geometry. So you're going to need to take some notes, and that calculator is going to be a necessary part of what we do today. So remember from geometry when we saw these two shapes and they were similar to each other, one was a little bigger size than the other, but the angles were the same, and we could find the values of x and y by setting up a proportion. That meant that we could compare, like this 8 matches with that y, the 8 compares to the y, just like this 4 compares to that 6. And then we would cross multiply. Remember, that's different than multiplying straight across. Cross multiplying is corner to corner like this. And basically taking our two fractions here and making them equal to each other gives us a way that we can turn it into a single equation without that fraction piece in there. So here's an algebra skill we need to remember. Make sure that you get this part in your notes. When you have two fractions that are equal to each other, we may cross multiply to solve the equation, okay? We may multiply, not across, but cross multiply. So here we go. Here's the first one that we should get in our notes. Here's an example of how this works. So when you cross multiply, we would take the 3 times the x plus 2 there. So that would make 3x plus 6. And then we would put our equal sign, and then we would multiply, basically they're called means and extremes. We would multiply the 9 times the x as well, giving me 9x. So we have two expressions that were equal to each other here, creating an equation that we can now solve. So notice I have x's on both sides. We're going to go ahead and move those x's together here. I'm going to subtract 3x, subtract 3x. So I'd have 6 equals 6x. Divide by 6. X is 1. So if we wanted to check it, we'd put that 1 here, put that 1 here, and we would see that we have 3 over 1 equal to 9 over 3. That's what that would work out to be, and the answer to that would be, yeah, 3 over 1 is the same as 9 over 3. So it checks. This idea of cross multiplying is very helpful when we're solving equations that have fractions involved. Let's do a little tougher example here. This would be an algebra 2 level, maybe algebra 1, depending. So 3 times 2x plus 4, that would turn into 6x plus 12. The 3 is multiplied by this and this term as well. Now we need to multiply these two pieces times these two pieces, okay? Be careful. That means 4 things, okay? X times the x would give you an x squared. An x times the 2 gives you 2x. But this x also gets multiplied by that negative 3, negative 3x. And the 2 gets multiplied by the negative 3, negative 6. We're taking x plus 2 times x minus 3. You have to double distribute there. Both pieces times both pieces. And so now if we see what we have going on here, guys, we have something with an x squared in here. That tells me that I'm probably going to need to factor to find my answer. I'm going to have 2 that I need to find. So I'm basically going to simplify this side here. X squared minus x minus 6 equals 6x plus 12. And then I know I need to bring these pieces over to the other side to hang out with the rest, leaving me with 0 on the right-hand side here, and I'd have an x squared minus 7x minus 18 equals 0. So now I need to factor what I have there. What multiplies to make negative 18 and would add to make negative 7? Negative 9x and 2x. So I'd have x, 2x, negative 9. This would factor into x minus 9, x plus 2. And now if I solve each piece, I get a solution of x equals 9 and a solution of x equals negative 2. So I ended up with 2 solutions here. Now, is it possible that one of them does not work? Or maybe they both work? Or what could happen here? Well, let's go ahead and take a peek. If we take these guys and we plug them back into the original, not your equation that you worked all out, but the original problem, okay? And we plug him back in. If I were to take that 9 and plug him back in first, it would become 3 over, this would be 9 plus 2 is 11 equals, this would be 9, 9 minus 3 is 6, This would be 9. 2 times 9 is 18, plus 4 more makes 22. So if I plug in the 9, I get these two fractions. Is that true? Is 3 over 11 the same thing as 6 over 22? Yep, they are the same fraction, just one's not simplified is all. But what if I take that negative 2? Negative 2 right here, take him and plug him back in. It would become 3 over negative 2 plus 2 is 0. Stop right there. Hold your horses. You can't have 0 in the denominator of a fraction. You can't divide by 0. So negative 2 is not going to work. Okay, he is not a good solution. So I need to cross him off. 9 is the only good solution for this problem. Let's take a look at a third example here. We're going to cross multiply and check our solution. So again, cross multiplying. 4 times an x plus 5. Well, 4 times x is 4x. 4 times the 5 is 20. Now x plus 1, that quantity, times an x minus 1. Again, distributing x times x first, x squared. This x times the negative 1, negative 1x. Positive 1 times the x, positive 1x. Positive 1 times negative 1, negative 1. Look at all those arrows, okay? Lots to multiply there. So now if we simplify, I have x squared. Look what happens here. No x's over there anymore. X squared minus 1 equals 4x plus 20. And now again, like the last one, we probably want to bring everybody else to hang out on the same side, so we can see what we have. Big 0 over there, x squared. We have a negative 4x then on this side, and a negative 21. So now I need to factor. What multiplies to make negative 21 and adds to make negative 4? Negative 7x and 3x would do that. So we'd have x, 3, x, negative 7. So we're going to put x minus 7 and x plus 3 as my two factors. Now to solve, remember, we're going to put equal 0 after each of them. And we solve, we get a solution of 7 for one and a solution of negative 3 for the other. Are they okay? Are these two solutions going to work? Are they both good solutions? Well, let's find out. Let's take that 7 and plug him in first. 4 over. If I put 7, 7, 7 back into the original, that'd be 4. Oops, I put a 7. 4 over 8 equals, the top of that second fraction would be a 6 over 12. True? Yep, 4 over 8 is the same thing as 6 over 12. They're both a half. So now I'm going to try the negative 3. Negative 3 here, negative 3 here, negative 3 here on this side. So 4 over negative 2 equals negative 4 over 2. Are those two things the same? Well, 4 divided by negative 2 would be negative 2, and negative 4 divided by positive 2 is also negative 2. So yeah, they're both the same thing. So these two solutions both work this time. See, not every time are we going to throw one away. It just depends on the situation, on that problem, okay? So be thinking about that as you're cross multiplying, and I want to thank you for taking good notes.